Notes 11.2, the Pythagorean theorem. What I'd like you to do is either before or after this lesson, I'd like you to Google the mathematician Pythagoras, okay? And do a little reading on Pythagoras and come in with just one piece of information, okay, about Pythagoras, all right? So, and don't just say, oh, the Pythagorean theorem, okay? So come up with one little interesting tidbit about Pythagoras, all right? So we're going to start out by solving these equations. So x squared equals 16. So in other words, what number times itself will give you 16? Well, hopefully you're thinking to yourself, well, I know that 4 times itself would give me 16. So 4 squared equals 16. But also, if you sit and think about another number, when multiplied by itself will give you 16, hopefully you're coming up with negative 4. Because if I took negative 4 and multiplied it by itself, I'd also get 16. So there are 2 answers to that equation. So let's do the same thing with number 2. I want you to come into class with number 2 done. Okay? Just like number 1. So let's talk about some right triangles. I'm going to give you a drawing first, and then we'll talk about the definition. So a right triangle is a triangle that has a right angle, and this little box would indicate in the in that little spot there that it's a 90-degree angle. That little box indicates 90 degrees. This is called a leg. This side is also called a leg. And this side has a special name that's across from the right triangle, the right angle. It's called the hypotenuse. Okay, and the interesting piece is about the hypotenuse is it's always across from the right angle, and it's the largest side of the triangle. It's the largest side of the triangle. So by definition, a right triangle is a triangle with one right, and we'll put in parentheses to remind you, 90-degree angle. And that's my little symbol for angle. I think we talked about that a few chapters ago. So in order for a triangle to be considered a right triangle, it has to satisfy the following equation. And this following equation, or sort of like a formula, okay, is easy to memorize. A squared plus b squared equals c squared. And it has a name. This is called the Pythagorean theorem. So let's talk about the parts to this equation, the a squared plus the b squared. This is the leg, one of the legs of the triangle. The b is the other leg of the triangle. And the c is the hypotenuse of the right triangle. Okay, so a squared plus b squared equals c squared, or you could say leg squared plus leg squared equals hypotenuse squared. Okay? So it says indicate whether the following are right triangles. So if this handy dandy little theorem here is going to determine whether something is a right triangle, that's what we're going to use in the following questions. So I like to start out and let's draw a picture. The first piece that we need to be concerned with is the biggest side. So 5 is my largest side, so 5 has to be my hypotenuse, because we said in the beginning that here that the hypotenuse is the largest side. Now it doesn't matter where you place 3 or where you place 4, those are the legs. Now I'm going to put these into my Pythagorean theorem. A squared plus b squared, does it equal c squared? And I'm going to see if I get a true statement. So leg squared, pick one of the legs to start with. I'm going to pick 3. I'm going to square it. Plus b squared is the other leg. Does it equal, and c is the hypotenuse. So the hypotenuse squared, 5 squared. Now is where I can go to my calculator. And I'm seeing if I get a true statement. So if you think about or put in your calculator 3 squared, you get 9. Plus 4 squared, you know, is 16. Does it equal 5 squared, which is 25? So what is 9 plus 16? And you know that it's 25 equals 25. Is that a true statement? Hopefully you're saying yes. Okay, that is true. So indicate whether the following are right triangles. Yes, this is a right triangle. 3, 4, and 5 are the sides of a right triangle. So let's jump down to, no, let's not jump. Let's go to number 4. So again, I'm going to draw my picture, my right triangle. And the biggest side is 13, so I have to put that one in the hypotenuse. And the hypotenuse is always across from the right angle. And the other two sides are the legs, and it doesn't matter where you put them. Now let's see if we can say leg squared plus leg squared, does it equal the hypotenuse squared? When you go to your calculator, you should get 25, or you know these, okay, because we did give you a little quiz on these. 7 squared, which is 49. Does that equal 169? So 25 plus 49, I could estimate that that's not going to equal 169, but let's see. So this is 14, 6, 74. 74 equals 169. That is a false statement. So are these the sides of a right triangle? No. When you get a false statement, it's a no. Okay. Let's do number 5. 3, the square root of 27, and 6. Now, from our first lesson, the square root of 27 is somewhere between 5 and 6. So my largest side is my 6. I could draw my picture. There's my right angle. My largest side has to be the hypotenuse. The other two are the legs. And now let's leg squared plus leg squared. Does it equal hypotenuse squared? So 3 squared, you know, is 9. Square root of 27 squared, okay, squaring and square rooting undo each other. So if they undo each other, they wipe each other out. So you're just left with, what's there? 27. Does it equal 6 squared, which is 36? So 27, or 9 plus 27 equals 36. That is true. When you get a true statement, you know that yes, these are the sides of a right triangle. You're going to come to class with number 6 done. Number 7 says find the missing side. So this is the hypotenuse squared. Or excuse me, that's the hypotenuse, is my x. So I say leg squared plus the other leg squared equals the hypotenuse squared. 25 plus 144 equals x squared. So 25 plus 144 is 169. So what number squared gives you 169? To undo that, their inverse operations, we'd say x is equal to the square root of 169 is 13. So we just found the hypotenuse of that triangle. All right, I'm going to give you a little challenge, and I'm going to have you try number 8. Let's do number 9 together. All right, let's identify the hypotenuse. It has to be across from the right angle. So the x squared is my hypotenuse. So leg squared plus the other leg squared equals my hypotenuse squared. That's my a squared plus my b squared equals c squared. 9 plus, remember, squaring and square rooting undo each other, and you're just left with the number that's underneath the radical. 9 plus 32 is 41. And to undo something squared, I take the square root. So I'm left with x is equal to, now is 41 on our perfect square list? It's not, and it can't be simplified. So my hypotenuse is the square root of 41. And the last one, we have to draw our own picture. It says a 5-foot ladder rests against a 4-foot vertical wall. So if this is my little brick wall here, okay, there's my brick wall. And we've got the ground. And we've got a ladder, okay, that's leaning up against this wall. Okay, so there's my ladder. And it says it's a 5-foot ladder rests against a 4-foot vertical wall. So I'm going to say that this is 4 right there. How far away from the wall is the foot of the ladder? So we're looking at this side of the triangle. So you're going to assume that that wall is forming a right angle with the ground. So my hypotenuse is the ladder. There's the right angle. So that's going to be my hypotenuse. So I'm going to say leg squared plus leg squared equals the hypotenuse squared. So just like any equation, we're going to move from left to right. 16 plus x squared equals 25. If I need to get x by itself, I've got to subtract 16. X squared equals 9. To undo something squared, I have to square root it. So x is equal to, and what's the square root of 9? It's 3. So that side of our triangle is 3.